Hello, welcome. Thank you for joining me today at the engineering talk. I won't be giving any kind of lecture today. This will be a very casual conversation as I take you in through a journey of what engineering is, specifically civil engineering, which is the field that I work in. So please make yourself comfortable, relax, and we'll get started. Before we dive into the engineering part of this session, I would like to take this opportunity to say thank you to Jenny from the U.S. Green Building Council for giving me the opportunity to be here today. If you have a chance, please visit the USGBC, U.S. Green Building Council's website to explore what they do and see some of the exciting projects that they have worked on. A little bit about myself. My name is Eugenia Lin. I am a California licensed professional engineer in civil engineering. I am a lead accredited professional in building design and construction. I am also an Envision certified sustainability professional. I am an engineering project manager at Metropolitan Water District located in Los Angeles, California. I am also a lecturer in Cal State LA, which is also in city of Los Angeles, California. I obtained my bachelor's degree from UCLA, and I got my master's degree in civil engineering and structural engineering from Cal State LA. This is a quick overview of today's agenda. I will go over what engineering and civil engineering is and show you some of the more commonly known civil engineering disciplines. And I'll give you a quick overview of what a civil engineer career path looks like. And last but not least, I want to discuss a little bit about sustainable engineering and how that is important to the future of engineering. Finally, I will also leave my contact information. So if you ever have any questions or would like to discuss anything with me, please feel free to reach out to me. So we hear the word engineering a lot. You probably have friends, family members, or know someone whose occupation is an engineer. But what really is engineering? Engineering, by definition, is an application of science and math by which the property of matters and sources of energy in nature are made useful to people. What essentially this means is all we do as engineers is we take everything that is available to us from nature and we make it either by converting it, designing it, modifying it. We make these items that we found or resources we found in nature and make it useful for human beings to make our life better, more efficient, and more convenient. Here's a list of some of the more common engineering disciplines you might have heard about. Computer software engineers, those are the folks that code or design the computer software so that they run on your computer when you turn on your computer. These are also the engineers who design the apps on your phone. Aerospace engineers are the engineers who design and send exploration rockets into the outer space. They're the one who you hear on the news that discover a new planet or a new black hole somewhere in the outer space. Electrical engineers, think about when you go home or when you go to school or walk into an office, you flip a switch and light turns on. That is because there is an electrical engineer somewhere who designed and maintained the power conveyance system so that electricity is easily accessible to all of us. Chemical engineering is a very broad field. These are the engineers that studies the chemical components of everything in our life. Most of the time, we will see more commonly chemical engineers in the food or food health science industry, or the drug and medicine industry. And some of the chemical engineers will work in the cosmetic industry because they look into the chemistry components of different items within our life. They're the one who ensures a new product is being designed and become useful to us. Mechanical engineering, I like to describe mechanical engineers are the engineers who design and build everything that moves. For example, a car, a machine, airplanes, or those aircrafts, or those rockets that the aerospace engineers sends to space. On the other hand, civil engineers, we build everything that does not move. For example, a building, the airport runway, or the highway or roadway that the car drives on. These are the works of a civil engineer. And of course, there are many, many other engineering disciplines that I did not mention. But if you do have a chance, look it up. There are many interesting fields of engineering, and one of them might be something that interests you. So who are civil engineers and what is civil engineering? Like I said, civil engineering is a study or a design of a system that does not move, something that is stationary or something that is a structure. For example, a building, again, the roadways or the highways, but that's not just it. There are also civil engineers who work on items that probably doesn't sound like engineering to you. For example, cost estimating. These are the civil engineers out there who estimate or come up with a cost for every project to make sure a project is built within the budget that is allowed. And there are civil engineers out there that works on specifications. They designate specifically what each component of a project needs to meet, the criteria that needs to be met, and the way, the sequencing of how construction needs to be carried out. So here are some disciplines in civil engineering. Water engineering are the engineers that studies, by definition, water. It can go from the resource, where we're getting water, to how water is being conveyed. When you go home, you turn on the faucet, clean water is accessible to you. And that is from a civil engineer who does water engineering specifically, from making sure that water is clean and being delivered to your house. Soil or geotechnical engineering are, by definition, are the engineer who studies the soil that your project gets built on. Structural engineers are the engineers that make sure that every structure that's being designed and built won't fall apart. It could be a skyscraper, it could be the home, the one-story house that you live in. From the roofing to the beams to the column and to the flooring, structural engineers make sure that the building that you live in is safe and it is comfortable for you to live in. Transportation engineers are the engineers who design and build the roadways or the highways or the airport runways or even railroads. And that is not just it. Transportation engineer also does a lot of forecasting. They make sure that the capacity of each roadway or highway is okay for the future depending on the forecast of the population growth of the city that you live in. Environmental engineering is a more unique discipline of civil engineering and used to be part of civil engineering. However, in the past few years, it branched off and became its own engineering discipline. So it's not a subset of civil engineering anymore. It is its own engineering discipline. But it got replaced by construction engineering. A construction engineering are the engineers who make sure that everything these other engineer has designed will be constructed and built in a safely, cost efficiently manner so that the construction can be successfully carried out. Here is a quick look of what each of these disciplines will look like. If you're one of those people who likes to look into different forces and pressure, the physics of force and kinematics, if you like geology or working in labs, you might consider a career in soil or geotechnical engineering. Because essentially what soil and geotechnical engineers do is that they analyze soil pressures and design a foundation that supports the structure. And by doing that, they analyze and make sure that the soil passes the test so that we know the soil that we're working with is strong enough. I like to say that geotechnical engineering is the foundation of all civil engineering work. By that, what I mean is, without the proper soil type, your structure will not hold and stand. So geotechnical engineering is the backbone of all civil engineering work or any structure that we build. And water engineering are really for those people who likes hydraulics. If you like fluid dynamics, you might consider being a water engineer. You might be building or designing a reservoir or a pipeline design. But that's not just it. If you just like chemistry, you might be a water engineer who works on water quality. Those are the engineers that make sure the water that is being delivered to everyone meets the specifications and the water quality standards. If you like hydrology, you might be someone who works on a water resource project. They're the ones that studies rainfall and how water will either accumulate or disperse in a specific area. Or if you just like public policy or even law, water engineering has a lot to do with compliance. For example, those water quality engineers, they want to make sure that the water they're working with meets the water quality compliance and the laws. And a lot of water engineer work on studying and changing policies. As technology progresses, there are always newer and better ways or newer products for us to work on a water project. And these water engineers are the ones who conduct the studies and make sure that laws or regulations are being proposed and changed accordingly so that we're caught up to the newest standards. And structural engineering, I always like to say most of the civil engineers became a civil engineer because they want to become a structural engineer. I say that also because I study civil engineering because I want to be a structural engineer. If you like to study statics or a force equilibrium, you might want to become a structural engineer to calculate and analyze the structural integrity. A really important subject, especially within the state of California, is that we encounter a lot of earthquake. So if you're one of those people who likes to study wave motions, or you're interested just in general how earthquake works, you could be one of the structural engineer who does the seismic analysis. And structural engineers are very good at reading codes that are very complex and different regulations. A lot of you might have heard of this. Every city has different codes or regulations on what is acceptable in your city. Some city will not allow certain billboards to be 8 feet high or 10 feet high, whatever they designated. They won't allow you to build a house that is too close to a fence. And every city has different codes and regulation about how a building or a structure needs to be built. And that is also a job of a structural engineer to make sure that whatever they're designing and building meets the code and regulation of different city or region. Or if you're just interested at different materials that you can use in buildings, either it's timber or you like to study concrete or reinforced concrete or masonry, these are all what material engineers do. Like I said, structural engineering is probably the most popular academic discipline among all civil engineers. A lot of us got into civil engineering because we want to be a structural engineer because it just looks so cool that we are the engineer that designed that crazy 200-story building in downtown somewhere. Transportation engineering. So if you like statistic and probability, you might consider become a traffic engineer. Traffic engineer, technically what they do at work is they study the traffic flow of a roadway or a highway and make sure that these traffic flow are being met and there is no terrible congestion in every city center. If you like geometry or trigonometry, a roadway or highway design might be something that interests you. You might not think about it, but if you look at the way that every roadway or highway, or even that ramp that goes onto the highway, is very carefully calculated and designed so that at a specific speed limit, your car is not going to fly out on a certain curve or a turn that you're making. And that is all a miracle of geometry and trigonometry work. And if you like to study materials and statics and soil, not only you can be a geotechnical engineer, you can also be someone in the transportation engineering discipline studying pavement. The asphalt or the concrete base on every roadway, these are all pavement design. And last but not least, construction engineering, the newest, most exciting upcoming engineering in civil engineering. These are for people who likes field work or you want to see something that's happening. You can be the construction manager or site inspector. For every project any other engineers design, we always need another engineer who is out in the field to make sure the construction goes as how it was designed. And if you like something like event planning, that is also something construction engineers do, because a very big part of construction engineering is scheduling and budgeting. We want to make sure that the project that we worked on is not being delayed and it's not creating extra costs for no reason. Or if you're just someone who likes logistics or you just like people management, you could just be that person that is in a construction site managing this construction project, or a project manager like myself. So I did study structural engineering, but when I started working, my field has always been in water engineering, and I am currently a project manager because I do like people management and I do want to make sure that every project gets carried out within schedule and within the budget. So here is a very quick pathway of how you can become a civil engineer. So I broke it down into a college level path and a professional career path. So when you're in college, every engineering school student studies almost the exact same thing in their lower division courses. We always start with calculus, physics, chemistry, and a little bit of maybe thermodynamics. But then when the engineers get to the upper division classes, this is where we divided ourselves. Civil engineer focuses on statics, strength of material, fluid dynamics, land surveying, and then once we get to about the fourth year, your senior year, you start choosing your discipline-specific elective. For example, if I am interested at becoming a structural engineer, I will probably choose a class on a building design or a seismic design. And like every other engineering student, we always go through a senior design project. Depending on what school we go to, a senior design project can be something that is easily accessible to, for example, designing a building in your school, or it could be something more exciting like a collaboration with a company or an agency that you design a real project in the industry. So once you get out of school, then we go into our professional career. As an entry-level engineer, this is where we start exploring your interest, and we learn about the industry. And this is when a lot of us will pass something called a Fundamental of Engineering, or the FE exam. A FE exam is very basic. It captures everything that you have learned in your college level classes. And you get tested in this 8-hour session to make sure you understand everything you have learned in college. And once you started working, that's when you really define what your future discipline is. Like myself, I studied structural engineer thinking that I will become someone who designed a skyscraper. But I landed on a job in water industry and I fell in love with it. And I think I am making it my full life career. So in the entry level, when you start your professional career, take the opportunity to explore different interests and different disciplines and find out what is something that really interests you. Once you gain your experience as an entry-level engineer, Every civil engineer will take this thing called the professional engineer exam. Very similar to the FE exam. It's an 8-hour, it's actually 2 days of 8 hours exam where the exam tests you on the actual civil engineering disciplines and topics. And once you pass that exam, you earn the title as a professional engineer or the PE. Then most likely you'll move on to an intermediate level or a mid-career engineer. This is most likely when you will lead a project. Once you pass that PE exam, you will get something called a PE stamp. It is a stamp that you can put on all different drawings and specifications. As a professional engineer, you're responsible for that project, the design, the specification, the budget. And by putting that stamp down, you certify that this work is yours and you take the full responsibility and all the credit for that project. And this is what we mean by you lead the project. The project becomes yours. You take all the credit and you take all the responsibility and you make sure that this project carries out as how you have designed it. And many engineers move on to a management position, and this is when you as a manager leads a team of different engineers, and this is where leadership became a skill, an important skill, because not only you want to work on a project and be able to answer technical questions, you are someone who will be able to lead a team to make sure the project is successfully carried out. So not only engineers are good at technical stuff. Yes, we all learn that calculus. We all learn how to perform calculation correctly. But once we started working, the chance of us performing a structural analysis or a calculation based on a very complex calculus or differential calculus solving a problem is actually not the majority part of our day. You'll spend 1 or 2 hours out of the 8-hour working days doing that hardcore calculation. Majority of the time, engineers work on problem solving in steps like how it's outlined here. Most likely, an engineer will start their problem solving in identifying a problem. There's always that one problem we're trying to resolve. If I were going to build a skyscraper, the first problem I will probably be solving is where should I place this building? Would it be in downtown New York? Or is it somewhere out in the deserts next to Arizona? And sometimes every project has different problem that needs to be resolved, and we don't want to group them all together and try to solve the problem all at once. We pinpoint the problem, divide it, because every problem actually will most likely have a different solution to it. Once you identify the problem, you want to find alternatives. There's always that one way that is the best way, but do not get stuck with only one solution. There are always different alternatives, and sometimes when you're exploring alternatives, you find a better solution than what you have originally envisioned when you start looking into the problem. And what's interesting in engineering field is that we always talk about this do nothing alternative. Let's take that building problem that we just talked about in step number 1. What if we don't even consider designing or building that skyscraper? Would that be a more economical solution? There might be issues. For example, this land that you consider purchasing is either too expensive or the soil condition is not even suitable for building a skyscraper. Do we want to even give up this project? That is the do nothing alternative. It might not be the solution to everything, but that should always be considered. And step number 3 is to consider your constraints. Again, look into the constraints. How big is your piece of land that you acquire for building that skyscraper? Is there city codes that won't even allow you to build something that is higher than, say, 4 stories high? Are there other issues within the area that you're working in? These are different constraints that you might think about before you even start designing your project. And make sure that when you're working on considering your constraints, go back to your alternative and compare each alternatives that you come up with and see how that solves your problem of the constraint. And step number 4, you want to look at the pros and cons and the risks of each of the alternative. There is always something that is good for each of your alternative, and there is always a risk or a con for the alternative that you are working on. Then you want to rank your risk and your pros and cons for each alternative. Of course, most likely you will be proposing or choosing that alternative that has more pro than cons and the least risk. And of course, step number 5 is to make the recommendation and test your recommendation. You pick that alternative that has more pros than cons and the least risk, but always test to make sure what you have recommended is actually workable or constructible, because a project cannot go on if what you have considered is not even realistic. So we solved the problem, and I want to just show you some of the cool things that civil engineers have worked on. This picture right here, this is called, those little black balls are what we call the shade balls. This is for water quality control and evaporation control in a reservoir in the back. About 2-3 years ago, there is a trending video on YouTube that discusses the Los Angeles Reservoir and the shade ball. And this is actually an idea that a civil engineer has recommended and got implemented. And it became something that is quite popular within the area for us to cover up these reservoirs with these little black shade balls. And what they do is that it blocks the water from being evaporated, because they're just little balls that covers the surface of water, which ultimately controls the water quality by reducing the bacteria and algae. So this is a picture I took over in the border of Los Angeles County and Ventura County, right next to Magic Mountain. So there's 2 significant structure here that were designed by a civil engineer. Of course, this highway, this is the 5 highway that connects Southern California all the way to Northern California. And I think it extends all the way to Oregon and Washington State. That is designed by a transportation or a highway engineer. But all the way on the top here, this is a cascade That is a water conveyance system that took water from Central California and conveyed the water down this pipeline and throughout the whole entire Los Angeles County and Los Angeles City so that people in Los Angeles have clean drinking water to use. So this is a picture of a construction site that I went to. This is a construction of a pipeline that is being installed. You might not see it, it's not very clear in this picture, but this particular pipeline is over 7 feet in diameter. It's way taller than me. I can walk through this pipeline. This crane is picking up this steel pipeline and lowering it into one of the construction pit to be installed. Down here, this is not in the United States. I do believe this is in the Middle East. I believe this was the tallest building in this world in Saudi Arabia. Of course, we want to have a good structural engineer for this project to make sure that this tallest building in this world does not collapse and is safe. Bridge building is another very important component for structural engineer. We want to have a safe bridge that is able to withstand for decades and decades and is able to withstand all the weight of cars or pedestrians that goes on that bridge. So that is a very important, significant work of a structural engineer in collaboration with a roadway or transportation engineer. And over here, this is a roadway that was either eroded or it collapsed because the soil condition, either it was from an erosion or earthquake. As I mentioned before, geotechnical or soil engineering is the foundation to everything of civil engineering. Everything that we build, including a roadway, it needs to have the stable and good soil analysis to make sure that this roadway or a building on top of it or the bridge that might cross this particular area, it will withstand either a flood or a snow condition or an earthquake. And this is why soil engineering or geotechnical engineers are very, very important. This is something that is very cool because I am in California, and again, California is very prone to earthquakes. This is a technology that was introduced to California within the last decade or so. This is what we call the seismic resilient pipeline. This pipeline itself is flexible so that during the earthquake, normally a pipeline that is solid does not move, which means if the earthquake is strong enough, it could rupture, or the force is so strong that it can break majority of the pipeline in half. But this specific technology was introduced from Japan, which is also very prone to earthquake. The pipeline itself is a flexible pipe, meaning when the earthquake hits, when the earth is moving, this pipeline will create a wave or move along with the soil or the land it sits on so that it absorbs the energy and dissipates it so that the pipeline does not break in half. I was fortunate enough to work on one of the projects that was installed in the Los Angeles area that introduced this technology of a seismic resilient pipeline in Los Angeles. So this is one of the cool and newer technology that I want everyone to be aware of. And I want to talk a little bit about sustainability and resilience. Sustainability and resilience go hand in hand. Um, what sustainability is it balances a healthy environment, economy, and creating an equitable society to our world. And another idea that is quite frequently discussed when we talk about sustainability is the resiliency of engineering. And it is both of sustainability and resiliency, they are both very important topic in engineering world today. Sustainability forecasts what will happen in the future, which means we want to prevent the change that's forthcoming, and we want to be able to prevent it in our project to make sure that our project will withstand the next decade or another 100, 200 years. It also reduces negative impact and makes sure that the society or the environment where our project is balanced and it's healthy. We don't want to build a project where it's going to be detrimental to our environment and harming the next generation and the world that they're living in. A little different from sustainability is the idea of resiliency. A system or a design that is resilient is long-lasting and reacts to change. Sustainability prevents change from happening, but resiliency reacts to change if change comes in. For example, in the previous slide, the seismic resilient pipeline is a resilient system that reacts to the change, which is the earthquake, and it mitigates the impact so that the system or the project that you build will not only reduce the negative impact, it mitigates it, and it will endure for a longer duration of time. And in engineering, what we like to say is to prolong the useful life of your design. And engineers across the world is taking sustainability and resiliency more and more seriously. We want to be able to build something that lasts a long time and be able to either withstand or react to different changes that we're encountering day to day. So here is some fun fact I would like to show everyone. Within the United States, this is a data that is from, I believe, 2019. Statistics shown we have 1.6 engineers that's employed across the United States. Out of all the graduates, some engineering graduates decided not to pursue their their career in engineering. But approximately 1.6 engineers are being employed in the US. And out of that, only 6% of all college graduates in the United States pursued an engineering degree, which means if you have 100 people in your college, out of that 100 classmates you have, only 6 of them will be pursuing some kind of degree in engineering. It could be civil engineer. It could be that none out of those 6 is a civil engineer like myself. And out of all the civil engineers, which is the 6% of the college students, only 22 who graduated from engineering school are female, which means only 22% of that 6 people out of 100 who are in engineering school are female. So I want to encourage all of you to really look into potentially either encourage yourself, or your friends, or maybe a cousin or a relative. We are in a shortage of engineers, and we are in a shortage of female engineers. Do spread the word and encourage those around you to look into, explore, and consider pursuing a career or a degree in engineering. So that is it for today. If you do have any questions, this is my email. If you want to talk to me, if you have any questions about anything that we talked about today, or if there's anything you would like to discuss with me, or just connect with me, even email me to say hi, letting me know how this presentation is, please do send me an email, and please reach out to me if you have any questions, and I will try to my best to answer your question. If I don't have the answer, I will find someone who has a good answer for you. Thank you so much for joining me today. I really appreciate you for being here, listening to my brief discussion about engineering and civil engineering. And I wish you all the best. Take care and stay safe.